Okay, so we are starting our new unit on just the equation. So the reason that we covered expressions first is because you have to have an understanding of how to be able to simplify those expressions before you can actually solve for an equation. You always simplify before you solve. So it's the process that we say you always do before you undo. Do what you can before you undo anything. Okay, so we're going to focus today on just the 1 and 2 step linear equations. And when we say linear equations, this means that if you were to graph it, its graphic representation would be a straight line. Okay, it means that it has absolutely no exponent on your variable. That's what makes it a linear equation. So we've been doing equations since y'all were in kindergarten, really. Okay, in kindergarten, they might say, what number plus 2 will equal 7, right? Or they'll say, oh, you have a basket of apples, and then you add 2 apples into the basket, and you now have 7 apples. How many apples did you start with? So you know that process, that instead of having a blank, they now put a variable. So instead of it being what number plus 2 will equal 7, it's now x plus 2 is going to be equal to 7. And you start doing what we call inverse operations. So another word for inverse is what? What's the word for inverse? What does inverse mean? It means what? A reverse or an opposite. Okay, it's an opposite operation or a reversed operation. Okay, you will always hear it being called the inverse operations, which just means it's the opposite of what you were intentionally doing. So if your equation is having an addition operation, then the inverse is going to be a subtraction. Okay, so the inverse of addition means that you're going to subtract, which essentially means that if you are starting with the value 3, and then I say, hey, you're going to add 9, and then you're going to subtract 9, it's as if this never happened right here. It's as if the adding 9 and the subtracting 9 never even existed, and you're just left with 3, right? Adding 9 and subtracting 9, inverse operations to each other. Now, please keep in mind that adding 9 and then subtracting a negative 9 is not the same thing. Okay, those are not inverse operations to each other. You must make sure that you maintain the sign of your value before you start doing inverse operations. So if your 9 was initially positive, it's going to remain positive as you are adding or subtracting it to either side. And then, of course, our inverse operations, multiplication and division. Multiplying and dividing are inverse operations to each other, or opposites to each other. My highlighter is running out. Let me try a different one. Oh, both highlighters are running out. Fantastic. All right, so again, if I were to start with that value of 9, and this time I said, okay, I'm going to go ahead and multiply 9 by 2, but then I'm going to go ahead and divide that by 2. It's as if the multiplication and the division never even occurred. Your value of 9 is just going to stay consistent here. Okay, so they are inverse operations. They are undoing each other. Yes?
It's kind of like zero pair, only for those two together.
Only with addition and subtraction would it be called zero pair. When it is multiplication and division, it actually does not come out to 0. It comes out to a value of 1. Okay? Because if you think about it, it's kind of like a fraction. Multiplying by 2 would be the numerator. Dividing by 2 would be the denominator. And 2 over 2 is 1. Okay, so when we are using multiplication and division, we tend to only focus on what's happening with our variable. Okay, so our variable never becomes a coefficient of 0, because if it becomes a coefficient of 0, the variable no longer exists. Okay, so addition and subtraction, yes, you could call 0 pairs, but not multiplication and division. All right, so taking a look here, problems 1 through 6 are some simple one-step equations. I want you guys to go through them very quickly, solving for the value of your variable. All right, let's go over it real quickly. So for problem number 1, what was the inverse operation that we had to perform there? Parker? well, so just division. Inverse operation, because it's showing us multiplication, right? It's already showing us that we're multiplying by 5. So instead of multiplying by 5, we're going to divide by 5. 5 divided by 5, we don't say that it cancels out, because what is 5 divided by 5? 1. So that's when we have a coefficient of just 1x. That's the goal. You want to get x isolated so that it has a coefficient of just a value of positive 1. Negative 1 is not considered to be isolated. Positive 1 is an isolated variable. But then you have to do the same to the other side. 30 divided by 5, and you should have gotten 6. What about number 2? What was the inverse operation for problem number 2? You guys shout it out, Jeremy. Addition. So instead of subtracting 8, we're going to add 8 to both sides. And again, here, just like Tanner had said, these are kind of like zero pairs because they are going to go ahead and cancel each other out. They are going to zero out. And you're left with a value of a positive 1x. And then you have to do the same to the opposite side. Negative 15 plus 8, you should have gotten x is equal to negative 7. Inverse operation for problem number 3. Jean-Luc. Multiplication. So instead of dividing x by 4, we're going to multiply it by 4. So if I multiply by 4 and then divide by 4, I'm just going to wind up getting a coefficient of a 1. So I can go ahead and cross them off. I now have x isolated, and then a half times 4 is going to come out to 2. Here, we'll go through these a little quicker then. For opposite of minusing 8, we're going to add 8 to both sides. Okay, so those minus 8 and plus 8s are going to go ahead and cancel each other out because they are going to zero out there. And you get m is equal to a positive 5. For problem number 5, the inverse operation you should have focused on was subtraction. So instead of adding 7.2, you're going to subtract 7.2 to both sides. Okay, these 7.2s are going to zero out. And you have x isolated. 8.9 minus the 7.2 is just 1.7. And then for our last one, number 6, 3/4 x. Even though it is technically a fraction here, this is multiplication. You have a rational coefficient. A rational coefficient is still solved the exact same way. The fact that you're multiplying 3/4 times x means that your inverse operation is going to be division. But as you guys should know, dividing by a fraction is really what operation? Multiplication of its reciprocal, right? You really are multiplying by the reciprocal of that fraction. But you can still indicate, hey, I'm dividing by 3/4. It'll come out the same way if you do 9 divided by 3/4 or 9 times 4/3. It'll still come out to the same value of x equaling 12. All right, go ahead and flip it on over to the next page. Don't worry about problems 7 through 10 yet. We're going to worry about those later. Okay? We're focusing right now on two-step equations. So for our two-step equations, actually I'm going to pause the video for just a second. All right, so taking a look here, the very first thing, like I said, if you're dealing with a two-step equation that is in this format, it's in this format where you've got a coefficient with your variable and you've got a constant and it's equal to a value, then you are always going to first undo the operation to your constant. Okay? And remember, the constant is the number by itself. There's no variable attached to it. Okay? Sometimes the constant might be written behind the variable. Sometimes it might be written in front of the variable. Like I could have rewritten this as negative 11 plus 2x. The negative 11 is still a constant, and I would still have to do the inverse to that. And the only way that we do the inverse operations to our constants is adding or subtracting. That is the only inverse operation that we ever do for our constant. So again, the constant is located right here. So if I were to go ahead and focus on undoing this, I would say instead of subtracting the 11, I would add 11. That's my inverse operation. I can then cross off the 11s, and I would be left with 2x is now equal to 16. Okay, that then moves me down to step 2. And step 2 is focusing on the coefficient or the divisor. Okay, and again, I apologize, my green is running out. Might have to steal another green. Let's see if I can steal one of these ones. Oh, that's much better. Okay. Pick them up later. All right, so when we're dealing with that, the fact that we've got this 2x is equal to 16, in order to get the x isolated, I would have to divide both sides by the 2. So then the 2's are going to simplify to a coefficient of 1, and I'd be left with x is now equal to 8. Okay, so it's just a double process right there. I'm going to do a couple of them with you, and then you guys are going to have the remainder of class time to finish the rest of the notes on your own. Okay, so 2x plus 3 is equal to 23. Again, the first thing that we're going to do is undo any addition or subtraction that we have in the problem to our constant. What's our constant in this problem? Ava, 3. So I'm going to go ahead and put a box around the 3, including the operation that happens to be in front of it. It says it's a plus 3, so my inverse operation is to subtract 3. And whatever I'm doing, I'm going to do it to both sides. Okay, then we've got 2x is now equal to 20. We can now move on to step 2. Step 2 is to do the inverse operation to the coefficient. So what's our coefficient? A 2. Okay, our coefficient happens to be a 2. So the inverse of multiplying by 2 is to divide by 2. So 2 divided by 2 becomes a coefficient of 1. 20 divided by 2 now becomes 10. So our value of x is just going to be 10. Now, I want you guys to get used to the process of showing your work, because 2-step equations and 1-step equations, yeah, they're pretty easy to do. Once you get into an equation like that on the backboard, trying to do all of that in your head, and let's say we throw some fractions in there, is going to get difficult. You're going to need to show your work. So starting from this point, when we do Delta Math, or we do IXL, you will be turning your work in. Oh, I know, Mason's gonna cry. Happy tears, he's gonna cry happy tears. Yeah, you are going to show your work. If you do not show your work, then the most credit you will be able to get for your assignment will be a 70. That's it. You will show your work, right? All right, let's take a look. X over 2 plus 5 is equal to negative 2. What's the first operation that we need to go ahead and do?
Addition. Oh, wait, no.
That's strong and wrong, man, okay? Strong and wrong. Subtraction. We're going to go ahead and subtract 5 from both sides. So that's going to leave us with x over 2 is now equal to what? Negative 7. Good. So we're going to have x over 2 is equal to negative 7. What's the next inverse that we need to do? Multiplying. What are we going to multiply by? We're going to multiply by 2. Multiply both sides by 2. The 2's can then go ahead and simplify to a coefficient of 1. So we get x is now equal to negative 14. Okay. Now, like I said, sometimes you will experience a problem that doesn't have the coefficient written in the back. Sometimes the coefficient might be written in the front. So I want you guys to go ahead, turn your paper over, and I want you to take a look at problem 10. Taking a look at problem 10. We have 6 minus 4x is equal to 26. What is the first inverse operation that I need to do? Who says addition? Okay. Who said subtraction? Okay. So how do we figure out who's right? What did I say to do? Put a box around your what? Your constant. What value is my constant up here? The 6. Is the 6 a positive or a negative? Positive. So let me ask you, if I add 6 to 6, is it going to get rid of it? No. The idea is to zero out your constant. But if you add a 6 to that, it's not going to zero it out. It's just going to make it a 12. It just gives you another constant. Okay? So even though we see subtraction, does that subtraction sign belong to the 6? No, it belongs to the 4x. Okay? So we're actually going to subtract 6 from both sides. Those will get canceled out here. And now what's left, that minus sign has to come down. And now instead of it being a 4x, it's now a negative 4x. Instead of it just saying minus 4x, it now acts like it's a negative 4x. Remember the importance of your signs for your terms. Okay? And that's going to be equal to 20. Now we can go ahead and divide. What are we going to divide by? Negative 4. Remember, you have to, with multiplication and division, you keep the sign the same. If you are multiplying by a negative, you're going to divide by a negative. If you're multiplying by a positive, you're going to divide by a positive. With your addition and subtraction, the sign's different, right? Because that's how we zero that out. So we're going to divide both sides here by a negative 4, and we'll get x is equal to negative 5. Okay? So what I want you guys to do, those couple of problems that were on page 2, problems 7 through 10 of the one-step equations, you're going to finish those off right now. And then you're going to turn back to page 3 and you're going to finish problems 3 through 12. We're going to go over the answers tomorrow. You need to show me that you have all of it worked out. So am I going to see only answers here? No. I'm going to see work. You are going to show work in order to receive credit. Go ahead and work.